Hello everyone, I hope you're all doing beautifully well. Today for something, well, it's interesting, it's just interesting. From Dumper Spidey Ho today. Hey man, the other day we did some dogfight training and I recorded some of it for the debriefing. I can't send the video as we do some classified maneuvers and things, yep fine. Got me thinking, I had the jet at 26 degrees of alpha. Now I'm going to guess that is sustained. Oh, it could be instantaneous, it could be sustained, I don't know. But that's what he was flying at, and probably because his aircraft that he flies, I probably shouldn't talk about what it is limited to 26 degrees, as I know some planes are. Could y'all maybe do a video seeing which aircraft can pull the most angle of attack before stalling? There's lots to talk about here, about what it means, why it matters, how we measure it. So, what are we trying to measure? Angle of attack. You all know what angle of attack is. If you don't, just Google it or just search Grim Reaper's angle of attack and we've got a video on it. It's incredibly important in any fighter jet or in any aircraft. One of the most important things to get your head around. So next, we need to think if we're talking about instantaneous angle of attack, which is the max it can pull just in one aft stick movement, or sustained. I'm going to go for sustained. The main reason for that is it's almost impossible really to quantify, empirically quantify instantaneous angle of attack, or really instantaneous anything. It's instantaneous turn rate, very, very difficult. If you can do it, you can go off to EM charts which are calculated on the plane and you can look at it there. But we're going to go for sustained because it's more in keeping with how I want these videos to work and what I'm going to go talking about. So we're talking about sustained angle of attack in a turn. Oh, another thing I should say that this is not about maximum sustained angle of attack in, for instance, an airshow high alpha pass, because you could get really high like that. You could get like 40 degrees maybe or something in a certain plane. What we're looking at is combat here. Actual usable, turnable angle of attack in a real life knife fight. So now we know what we're looking for in a knife fight, sustainable angle of attack. So why are we interested in this? And even are we interested in this? What things help in a knife fight in terms of kinematics? Well, obviously you thrust and you lift and stuff like that, but those really equate to something bigger. They equate to, first of all, turn rate. Let's go sustainable. Let's not go instantaneous on this for the reasons we described earlier. Sustainable turn rate is the amount of degrees a second you can go round a circle. If your aircraft can sustain at the set parameters of what we're flying at in the turn fight, can sustain 26 degrees per second and your opponent can only sustain 20 degrees per second, you've got 6 degrees per second delta on him and you'll catch him up around that circle and eventually you'll get on his tail and there's nothing you can really do about that. That's what I would personally consider probably the most important thing. And I'm not an expert or anything, but you know, I've been doing this for 5 years. So. The next, I think, most important thing is going to be a culmination of other attributes, which is going to turn up to be minimum radius of turn. So instead of how quickly you can go around the circle in terms of degrees, how tightly you can turn. So let's say that you've got the same degrees per second, the same turn rate as your opposing guy, but you can turn in a tighter, smaller radius. And this is something I've just learned more recently from doing a little bit more serious dogfight analysis, is that the guy with the smaller radius turn will always have the advantage because he can always control the fight. And I can't explain that in a geometric sense because I'm not smart enough. You'll probably have to go to Lemoyne or someone to explain that. For instance, if you've got, say, an F-14 with 26 degrees per second turn in optimum condition, fighting a Spitfire with 26 degrees optimum turn, so they both turn around the circle at the same time, but the Spit can turn in 500 feet radius and the Tomcat needs 2,000 feet radius, the Spitfire will win because it can keep inside of the turn and therefore it can still control the fight. There's very little, in terms of knife fight, I don't mean extending and going upwards and stuff like that, but pure knife fight, pure circle fight, I mean, then the Spitfire can win that. So that's the second thing. Sorry for taking so long, but I need to clear it up in my own mind as well. Now, the third thing we're looking at here is angle of attack. With minimum radius being the same and turn rate being the same, between fighter A and fighter B, will the guy with the higher sustainable angle of attack have an advantage? My logic, I think it will. So all else being the same, our imaginary fighters, one can sustain a maximum of 15 degrees angle of attack, and let's say you get another one that's a Hornet that could sustain 40 degrees angle of attack. I think the 40 degrees angle of attack will always have the advantage because it means that going around the circle of our knife fight, it means that the guy with higher angle of attack can keep his nose pointed more at the bad guy than at the vector of the circle. It means his weapons employment is going to be easy, getting a lock's going to be easy and so on. Ignore helmet mounted sights and stuff, just basic kinematics of the fight. So I think sustainable angle of attack is not as important as turn rate, not as important as turn radius, but I still think it's an important thing. Again, just talking about sustainability, not instantaneous. I know the Hornet can do a huge instantaneous pull in a JF-17, but that's going to be a bit too hard to measure. Next, we're going to talk about the test itself. I mean, why would there be a limit to the angle of attack of a fighter? All planes will have a limit to the angle of attack based on their airfoil, their body design, the thrust they put out, and so on. As they go around the circle, and as their angle of attack increases, the amount of body and wing area they're presenting to the airflow will grow bigger, obviously. Just picture it in your mind. And therefore, drag will increase probably exponentially, or at least at a high rate as your angle of attack goes up. At a certain point, the force induced by the drag induced by the increasing angle of attack is going to become greater than the force of the thrust pushing you around the corner. Now remember, as angle of attack goes up, the effective thrust goes up because the vector of the thrust is changing in terms of how your aircraft is going around that circle. So at a certain point, there becomes a stall point. Let's say you're in an F-15, you're pulling the stick harder and harder, the angle of attack is going up and up, the speed's coming down and down. At some point, there's a crossover where you can no longer maintain that angle of attack because drag is becoming more than the thrust. I think that is what Dumper Spidey is really getting at in here, and that's what's going to be something that's actually useful for us to test. Which plane can maintain the highest angle of attack? In terms of the variables and the constants, let's keep as much constant as possible. They're all going to be ISA conditions. They're all going to be on the deck. They're all going to have the same fuel consideration, say 10% fuel. So that's all going to be the same. The speed will have to differ. All of these aircraft will find their max sustainable angle of attack at a different speed. Some might be 300 knots, some might be 200 knots, some might be 150 knots. All of these aircraft will have limiters. For instance, an F-16, we all know, is an angle of attack, a limited jet. Its maneuverability is limited by its angle of attack, which is limited by its fly-by-wire. I think it's 26 degrees, might be 22, I've forgotten, but whatever it is, that's what it is. Other planes limited similarly, JF-17 and so on. Some planes are not limited in angle of attack, or not as much at least. A Hornet, for reasons I'm just not clever enough to understand, I think is not limited in angle of attack. It's limited in other ways, I stand to be corrected, but I think that's how it works. Tomcat, don't think has any limit. Vigan, something like that. In some of these aircraft, you can turn the limiter off, but I don't think you realistically would in a dogfight. F-16, you can turn the alpha limiter off. JF-17, you can turn the alpha limiter off. But if you read the manuals, it's not for dogfighting. It's purely for crash recovery. So if you do a stall, you can get a few moments extra angle of attack just to escape. I don't think you're allowed to use it in a dogfight. In the Sukhoi, in the flanker, you can turn off the alpha limiter. In fact, you can turn off the pitch fly-by-wire pretty much, or augmentation altogether. Maybe we'll have a look at that, but again, the average guy is not going to be able to do that in a dogfight. So anyway, that's my synopsis of what's going on. In terms of predictions, honestly not the foggiest. I know F-18 is really good at holding high sustained angles of attack and controllability and not stalling. I think because of its big lurkses. Again, I stand to be corrected. I'm going to put my money on that and maybe the flanker with its fly-by-wire turned off, but probably not, to be honest. Stand by for the test. Okay, valued viewers, I will be doing half the jets. RC will be doing the other half in the background. The first one we'll spend quite a lot of time on, just to show you how I'm doing this, and then the others will just breeze through. I've already explained the conditions. ISA, 10% fuel, but fuel burn turned off, blah, 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 blah. And all the settings of the plane normal. Oh, that's an interesting track IR solution. Let's try that again. You can see the angle of attack, speed, and you see all my credentials down the bottom. All of these max sustained angle of attacks are going to be found at a low speed. That's just how a jet flies. So we're going to get way below 250. Right, we're going to get max power. Everything will be done with max power, needless to say. So it's all about getting a feel for when the drag of the high angle of attack is going to exceed the effective thrust. Take us around the circle. And depending how powerful the plane is and, you know, how it's built, we're going to find that in different places. Also, the restrictors are going to come into play. Pause there. I've got Spark. It's not really a fly-by-wire, but it's an augmentation system here that's going to control these things for me so that I don't pull too high angle of attack. If I took Spark off, this may not be modelled in DCS because DCS is not a true, you know, modelled flight engine per se, but when you take things like this off, but what would happen probably in a real Vegan is you'd be able to turn such a high angle of attack, it would just immediately cobra and still going.
Are we doing the F5?
Yeah, I get the F5 done, yeah. Same considerations. Right, anyway, let's ramp up that angle of attack. I'm sustaining 20 degrees. Oh, actually, scratch that. Balancing the aft stick. I'm going to see if I can find the outer limits of Spark. 2021, we'll round up to the nearest angle of attack and try full aft stick. Okay, yep, Spark's taking control at this point. At this point, I don't actually have control of the aft stick anymore. Spark's limiting it for me to keep me from stalling, and it's decided that that's it there. 160 knots. The engine started flaming out. Just ignore the engine flame outs. It's 23 degrees. Spark allows me up to 23 degrees at about 160 knots. That's the first one done. Make sure you record the speed as well, RC, because that might be important. So the speed and the angle of attack. What's my next plane, RC?
Carrier.
Now this is interesting, valued viewers, because Harrier has vectored thrust. We'll try it with and without vectored thrust. I think that's going to be a really interesting thing to do. I think that turning those nozzles, viffing, is going to give us a little extra alpha. Now the question is that going to be instantaneous sustainable alpha, or... sorry, is that going to be instantaneous alpha and unsustainable, or sustainable alpha? I don't know.
7-0.
Okay, can you write your own results down, because I'm going to be in.
Yeah.
I'm going to be doing testing.
No, you... I'm not writing your results down.
And make sure, RC, every time you change the plane, make sure you've set it to 10% fuel, because it will reset itself to maximum, and that completely ruins the results.
Oh, then that's the problem.
How embarrassing for you. Off you go to do it again. Nozzles fully back. Nozzles. This will probably be terrible. I imagine the alpha flying characteristics of this plane are going to be terrible. I don't think it's going to translate very well at all. I can already feel it's hitting an aerodynamic problem. I don't know what to call it. Yeah, see that? How I kind of rolled left. That wasn't me. That was a wing stalling or doing something weird that I don't understand. That's the limit in this particular aeroplane by the looks of it. So let's try that again. See if we can, right on the edge of that stall. You see the speed suddenly plummet uncontrollably. So bear in mind that throttle is a constant. The only variable here is, for me, is my aft stick. It's really going to be really hard to quantify. I think that's 17, 18, 18. Yeah, it can't go any more than 18. It stalls at 18 and a half. Let's go and try it with a vectored thrust. Now, I did some testing of this before, just theoretical testing, and the optimum appears to be if you set the nozzle thrust to the angle of attack where you're topping out. So let's set it to, say, 20 degrees. Then it's going to give us a little bit more actual usable vector thrust. Like I don't really know the terminology for it, but if you know what I'm talking about, you'll know what I mean. It might be the thrust isn't going to help. It might be that the wing just can't do this angle of attack. $17, 18. It's just the same. You can do it slower, interestingly. Yeah, exactly the same. Once you get to 19, it just goes. That's it. What's next on my list, RC?
F-16.
Oh, right. This is an alpha limited aeroplane, so we already know the limit is just whatever the alpha limit is. We just need to double check it is 26 degrees. Saying that, it might not even reach its alpha limit. Well, we'll see. I don't know. It's really powerful and light aircraft. It's got lurxes and it can handle angle of attack well. We all know just from, well, just everyone knows it. The stream's saying don't black out. Now that's interesting because you won't back out from this because the speeds are low. The centrifugal forces are very low as well. So you cannot black out like this. It's not possible. It's just how it is. Oh god, this plane is. It's a really alpha-friendly plane. It likes to be an alpha all the time for some reason. 21 degrees. Still completely controllable. It's all sustainable. 22 degrees. It's going to beat the Vigan. I can pretty much probably just pull full aft stick here actually and let the fly-by-wire do it. This thing. Okay, that's it there. 195 knots at 23 degrees a second. I'm pretty sure the plane can actually do more angle of attack, but at this point it's just decided aerodynamically, for whatever reason, that it's going to be 23 degrees. I can't get any more than that, so F-16.
Well, I think the 14 was around 27 degrees.
Yeah, I'll probably have to confirm that because that's a very complex plane. Now the viewers are going to say flaps or no flaps. Gee, what's going to help more?
I'd like to review the rest of them.
I'm going to do flaps, I think. Okay, Tomcat, the beast from the west. 20. Yep, see what you mean. This is not easy. Lots of pilot skill needed to fly this plane. Right, I've already ruined it. Brilliant. Why is this plane so hard to fly, I'll see. Right, are my flaps down? No, they're not. That doesn't help. Okay, maneuver flaps, valued viewers. I think they'll probably help my angle of attack. And it is something you'd realistically do. It's how we were trained to dogfight. 14 degrees. It's so hard to do this.
Yep.
It's once it gets to that 20 degrees angle of attack, it just it loses a wing and it just rolls out.
I got it up to 27.
Yeah, but it's got to be sustainable. You've got to do a whole circle with that 27. That's the problem. We're not looking for instantaneous. A whole circle done at that.
I had it held for a bit. Yep.
I can't do it. It
No flap.
just loses a wing for me.
I mean, I've got the Hornet at 26.
Yeah, well, that's an amazing aeroplane, that is. I can't get past...
I'd say 26 at 180. Yeah. No.
That's amazing.
Yeah. It's giving me stall warnings, but it's not falling out of the sky. So.
I can't get past 21, the Tomcat. It gets... The speed starts to reduce. I'll try without flaps. I don't think it's going to help, though.
Oh, I'm up to 28 at 160. Oh, now I'm falling out. Okay, so that's... No, still... Okay, 26 at 170, that's...
Fuck it, I can't really sustain above 20 degrees in this thing. What I'll say is, valued viewers, if you can beat our results and send proper videos in of you doing this in the same conditions, then I'm always happy. You know, you guys are better pilots than us at the end of the day. I'm always happy to update the results.
They think everybody's a better pilot than us?
Pretty much.
We never fly the Tomcat.
No, we don't never fly anything. We fly everything. So we're not really good at anything.
We never fly Tomcat because of the tracks. Alright, well then my next one is a Jeff.
What was the F-18?
26 at 170.
Wowza. Did you say 28, or is that unsustainable?
No, I couldn't get it to stay up there.
What's the next on my list?
Mirage.
Now, the valued viewers are saying that Mirage should do well because its delta is designed... It just works well with high angles of attack management. Is that because... It must be because center of... I don't know. Someone needs to explain why that is. For some reason, the V shape seems to work well with high angles of attack. One winning so far is the F-18, which is actually what we predicted. The big surprise of the day is the AGS-37 is amazing. Value viewers, Mirage 2000C, kinematically, this is a wonderful plane. I always used to slag it off because I used to say it's unrealistic, it's too good. Lots of people I've spoken to seem to be happy that it's realistic, you know, people that really know about this stuff. My problem with that is, okay, well, why doesn't everyone use a Delta design if it's so good? Why did the F-15 turn out like it is? That's where my problem comes with it.
Right. Jeff just wants to keep going and going.
What a surprise! Yes, I think it can go about 2,000 angle of attack degrees. Not allowed to say that, I'll say.
And I don't think there's a limiter. I don't think you can take a limiter off.
Well, you can, but you wouldn't do it in a dogfight. I remember we did a video about it to do the Cobra, if you remember.
Oh, yeah.
This fly-by-wire is top-notch on this thing, so I'm just going to half-stick it.
I've got the stick all the way back, and it's at 612 miles. 629 kilometers per hour.
Oh, you're struggling with speed?
Yeah.
Okay, I can probably find a way around that. Let me just do this first. Wow, this is amazing. Look at this, guys. It's clearly limited to 160 knots and 26 degrees alpha.
You can have the Jeff, and I'll take the next one.
All right, Wilco.
Right, then the 21 we're not doing, right? Too old.
I don't know, we'll decide at the end. But that is, you guys got to tell me why that can sustain so well. I mean, it's even beautifully controllable at 26 degrees alpha, 160 knots. It feels like it could do that all day, which it can, obviously. So what is it about those wings? What when I'm doing the Jeff?
Yeah, I do the Jeff. I couldn't get it to slow down. So.
Roger. Yeah, it's just knowing the fly-by-wire systems well enough. You know what? This is such a competent system. I'm just going to go full half stick like the Mirage. It'll probably manage it all itself. Okay, we can see there 26 degrees, which is what it's managed to do.
Angle of attack.
Or is it going to stall? Yeah, no, that's right. Yeah, perfectly manageable. 150 knots, 26 degrees. Is it those lurkses again that are doing, allowing it to do that? They must be, right?
All right.
What's the 20? What was that?
That's 29.
Wow, 25. Yowza.
29. Yeah, 25.
At what speed?
160.
That's really impressive, actually. That has big lurkses as well, doesn't it? It's 25.
It's hard.
What
It's
was that?
not-
The A model we've got there, because that's kinematically better.
Yeah.
Right. What am I on next?
All right, your next one will be the SU-27.
I'll do the 27, you do the 33 then. Okay, valued viewers, that's the MiG-29. Now we're going for the two flanker variants. There will be, the 27 will be better. It's kinematically better in every way than the 33. Stand by. So normal, no limit. Sorry, limited. Again, it's a pretty good, robust augmentation on the pitch here. So I'm just going to full back stick it. Interestingly, I can't get my controls up for some reason, but never mind. Oh, of course I pressed the wrong button. Right, 190 knots, 22 degrees angle of attack. It's a big thunker. The problem with this is its thrust to weight ratio is not that good compared with the others, and it's a massive drag machine. It's created so much drag, especially in the angle of attack. I guess hence parts of the Cobra maneuver. So you can see we've got it stuck there at 180 knots at 22 degrees alpha. Right, so next I'm going to try thrust the stick limiter. Whether it's going to have any difference, I'm sure it will. Yeah, no, this is the angle of attack limiter. So, sorry, I was talking BS before. I can turn off just the angle of attack limiter with the Y key, but not turn off the whole augmentation, so I can make it manageable. Let's see how that goes. So, Y. We've now turned off the angle of attack limiter. Let the burners kick in. Off we go. Right. Now, I'm probably just going to fall out of the air at this point. I definitely did it. Just maintaining just the same. Try Y again. Yeah, it's the same. Whether Y is on or not, it's going to sustain the same.
Shouldn't be any different.
No, because with the whatever I'm commanding is more than the plane can fly at. I'm commanding all of the alpha. The plane can only fly due to the shape of its wings, due to its weight, shape of the body, thrust, and so on. It can only fly at a certain sustainable thing, and the augmentation system will tell me what that is. Let me try with augmentation off, just out of interest. So pitch augmentation going off. This will not be pretty, but it's just purely as an already I'm struggling with it.
Oh.
So I can now command exactly what those stabilators, elevons, whatever stabilators do. 26, and I just haven't got the skill to do it. I need a proper flanker driver. If you're a proper flanker driver out there, go and see what you can manage and send me proof, and I'll update that. Oh, UF-15. Okay, for the lols, I'm going to do the MiG. This is going to be the worst angle of attack machine ever created by man. Man didn't create it though. Stalin created it. This is going to be ridiculous in every way. Combat thrust going on. F-15 will manage itself. It's got good pitch augmentation.
Oh no, it's having issues.
Sounds like an RC problem. Honest. Combat thrust on. Watch this, valued viewers. Watch this engine flame out. Wow, I'm getting horrendous FPS. I'm glad it's not just, and this is an empty map. Glad it's not just me that was imagining that. Oh, the wings are still at 14 degrees angle of attack. Ah.
Yeah,
Cannot
it looks like
do
22 at 200.
Alright, I'm in game at the moment.
Yeah. It's not as good as you think.
Roger. Again, and we'll talk about the reasons, this is terrible. This is 13 degrees angle of attack. There's not much in the F-15's body that looks like it could create a high angle of attack. There's no lurks, there's no, F-15, 22 at
200.
Okay, valued viewers, welcome back to the data. There's nothing that turns me and RC on more than a good set of accurate, reliable data. So here we've got added to our giant list of every variable measurable pretty much in DCS that we can find. We've got max sustained angle of attack at 10% gas ISA, blah, blah, blah. From the top, we've got the FA-18C, and that's pretty much what we thought because it's just known as a good at flying at high angles of attack. 170 CAS at 26 degrees angle of attack. Jeff, the same 26 degrees. Now, interestingly, at a lower speed. Now, I wonder what would be preferential, a low speed or high speed? What would be superior? I can't actually figure that out, so let me know what you guys think there. The angles are accurate to nearest degree. The speeds are probably plus or minus 10 knots, I imagine, because it's just not that accurate to measure. Jeff, Mirage. Mirage, as the viewers on the stream predicted, Mirage would be good for reasons I don't really understand. 26 degrees per second, and probably the most controllable at those speeds. It was basically flies almost perfectly. 160 CAS plus or minus. Real surprise of the day again, MiG-29. I really wasn't expecting that. 25 degrees angle of attack at 160 CAS. F-16, 23 degrees. Why couldn't it get up to its limit of 26 or whatever it is? You guys let me know. I'm going to try it yourself. Make sure. I mean, there's always a chance I've made a cock up. I forgot to take the fuel out or something. So if you guys find a mistake I've made, let me know. Send proof and I'll update it. But for some reason, I just couldn't get it above 23 degrees. And I couldn't get any slower than that for some reason. So I don't know. I'll have to you guys will have to let me know what. AGS-37, really surprising. Can fly a really high angle of attack in a turn, the same as an F-16. Who would have thought that? I wouldn't. But Schwark allows it for whatever reason. So there you go. F-15, bit of a disappointment, and we'll talk about maybe why in a bit. Interestingly, is at the high speed. So I don't know. You guys let me know. 27 and 33, both 22 degrees per second, limited. I think that's limited. 100, plus or minus. It's probably the same speed, more or less. I imagine. Very similar aircraft. This one's a bit heavier and a tiny bit more lift, but. F-15 with or without flaps. This was a real struggle. We may need some better F-14 pilots to go and confirm this. RC said he could get 27. I mean, by looking at the data, that just doesn't make sense. I found about 20-ish before it just, gets uncontrollable. So you guys let me know what you think about that. 200-ish CAS. Again, it was hard to measure. Harrier was quite bad, as we thought it would be. 18 degrees angle of attack. In fact, I'm surprised it was that good. At 240 CAS, we've not. I've done that the wrong way around. F5, which is what it is, 18 degrees angle of attack. I don't think anyone expects it to be particularly good. MiG-21, oh, that was so bad. 13 degrees angle of attack at 220 CAS. Wowza! That does not do angle of attack. Now, I've put a star, an asterisk, on a plane that has obvious lurkses. An F-18, Jeff, a Mirage, we'll come back to that. A 29 has lurkses, 16 obvious lurkses, 27, 33. And the AGS-37 and the Mirage have not lurkses per se, but they kind of sort of have lurkses in a way that they have a wing right up front, kind of near the nose. Obviously, the Mirage has a kind of high tapered wing up near the nose, or you know what I mean, near the front. That's about the best I can describe it. The Vegan has the four planey canardy type things, the four wings up. Is it a coincidence that the planes with the lurkses slash the canard slash the bit of wing up the front pretty much occupy the top half, where the planes without it, F-15, F-14, AV-8, are all down at the bottom? Let me know what you guys think of that. I thought an F5 had a lurk, so I may be wrong. But and we'll just discuss some basic physics and see what you think. I found that really a good thing to do. Thanks for our chap for suggesting that. Just great, really. Nothing bad to say about it. Anything you want to add to that, RC?
No.
Hope you enjoyed that. See you later.